In this video, we'll be solving some absolute value inequalities. Absolute value of a number a, written with the vertical bars around the argument a, gives the distance from a to 0 on the number line. Now, if we have the absolute value of x is less than 3, that means that x is within 3 units from 0 on the number line. So 3 units to the right and 3 units to the left, my x is less than 3, so it's within this span between -3 and +3, not including either of those endpoints since this was strictly less than. So the solution for this inequality then is x is between -3 and +3. Or if you wanted to show this with interval notation, you would write it as -3 at our left boundary and +3 at our right boundary. If you're working with absolute value of x is greater than 3, this means that x is more than 3 units from 0 on the number line. So 3 units to the right is +3, 3 units to the left is -3, and I want numbers that are more than 3 units away from the 0. So they have to be out here, more than 3 or less than. And again, this is strictly greater than, it's not greater than or equal to. So my solution set then would be x is less than -3 or x is greater than +3. And again, if you have interval notation that you're using, then our left boundary is -∞, and I'm going all the way up to -3. Union with the interval from 3 to +∞. So our properties of absolute value will be used to remove the absolute value bars Now, if we have inequality, then if it's absolute value of a less than b, remember that this was the one that was in between the two. So this was -b and this was b, and it was in between there. So to remove our absolute value bars, you write this statement, this 3-part inequality. If you have the absolute value of a greater than b, remember that one was the one where we went out away from the endpoints. And so when you do that, when you have absolute value of a is greater than b, then you have to write 2 inequality statements. A is less than -b or a is greater than b. So let's do a few problems. I'm asked to solve absolute value of 4x minus 6 is less than 10, and then give the solution set in interval notation and a graph. Well, in order to remove these absolute value bars, I need to use property 3 because I'm dealing with absolute value less than a number. So absolute value less than a number, I have to write a 3-part inequality with my argument from the absolute value in the middle. So let's do that. So we have 4x minus 6 is the argument from my absolute value, and that's going to be in between, and then I want the 10 over here on the right, and then negative 10 on the left. Remember, when you do a three-part inequality, if you're using less than, these need to be in numerical order. So negative 10 is to the left of 10, so it needs to be over here on the left. All right, now let's just solve this. We're going to add 6 to all three parts so that these cancel off, and negative 10 plus 6 is negative 4, is less than 4x, which is less than 16. And then divide all three parts by 4. So 4. These will cancel, and I have x is between negative 1 and 4. So the direction says to give the solution set in interval notation. To show x between negative 1 and 4, my interval would be negative 1 to 4. And I use parentheses here because these are strictly less than symbols. There's no little line underneath. And then I also need to graph it. So my graph would be from negative 1 to 4. I want all the points in between there. And I'm not including either endpoint. And this is my solution. I'm asked to solve absolute value of 4x minus 6 is greater than or equal to 10, and then give the solution set in interval notation and graph it. All right, so we need to remove the absolute value marks. We're going to use property 4 because this is a greater than symbol. And so property 4 says I need to write two separate inequalities. So the first one is 4x minus 6 is greater than or equal to 10. So you're just grabbing that without the absolute value bars. Or, and then take the argument 4x minus 6 is less than or equal to negative 10. Let's add 6 to both sides here. These will cancel. 4x is greater than or equal to 16. Divide both sides by 4. And these will cancel. X is greater than or equal to 4. Or, and then we'll do the same thing. We'll add 6 here to both sides. These will cancel. 4x is less than or equal to negative 4. Divide both sides by 4. These will cancel, and x is less than or equal to negative 1. Now to write my solution set, let me graph these first. I have 4 and a negative 1. So on the number line, my negative 1 is over here to the left of the 4, so I need to do that. And I want all my x's to be bigger than or equal to 4. So bigger than would be to the right of. And since I'm including my boundary, I have to use a squared off bracket. And then for this one, I want my x's to be less than or to the left of negative 1. So all of these points, and then a squared off bracket here to show that the boundaries are included. So here's my graph. Now the interval notation is from negative infinity up to negative 1. Include the negative 1. Union with, and then for this interval, I have 4 up to infinity, and I'm including the 4. So I have bracket 4 up to positive infinity. So these are my two ways of showing the solution set. On this one, notice we have absolute value greater than, but I need to isolate my absolute value first. So I'm going to subtract 6 from both sides so that the 6 is off of the left-hand side. Then I have absolute value of 5 minus 8x is greater than or equal to 8. So you must isolate absolute value first. Once you have it isolated, then you can choose the property that you're going to be using. I'm going to use property 4 because this is greater than. So I need two disjoint statements. My first one is just straight from my inequality. And then my second one, this is greater than 8. My second one is 5 minus 8x is less than or equal to negative 8. So let's solve this. Subtract 5 from both sides. This will cancel. Negative 8x is greater than or equal to 3. Divide both sides by negative 8. These will cancel, and x. Now whenever you multiply or divide by a negative, remember you have to flip that direction of the inequality. So instead of greater than, now I need less than or equal to, and then negative 3/8. On this one, subtract 5 from both sides. These will cancel. Negative 8x is less than or equal to negative 13. Divide both sides by negative 8. And x is greater than, remember to change the direction of your inequality, and this will be a positive 13/8. So let's look at our graph. Our 2 points are negative 3/8 and 13/8. So my negative 3/8 is to the left of 13/8 on my number line. I want all my x's to be less than or to the left of negative 3/8. So that's these numbers. And I also want x's to be greater than or to the right of 13/8. And that's these numbers. And I have the little line under my inequality, so I need the bracket to show that those endpoints are included. At the interval notation, I'm going from negative infinity to negative 3/8. Union with, and then from 13/8 to infinity. Oh, I need to include, this should be a squared off bracket, sorry. Um, 13/8 to infinity.